When you get into your car and drive down the highway, the math is simple. You measure your speed in miles per hour or kilometers per hour. It makes perfect sense. You are measuring a distance across the land over a specific amount of time. But the moment you step onto a boat or strap yourself into an airplane, those rules disappear. Suddenly, nobody cares about miles or kilometers. Instead, the captain speaks in knots. But why? Is a knot just a fancy word for a mile? Is it measuring a rope? And why, in an age of GPS and satellites, do we still use a unit of measurement from the 17th century to fly high-tech jets? The answer involves a wooden log, a sand glass, and the shape of the Earth itself. Welcome to Simple Things Surprising Histories. Today, we're untangling the story of the knot. To understand the knot, we have to go back to the 17th century. Back then, ships had no GPS, no radar, and no digital speedometers. But knowing your speed was a matter of life and death. If you didn't know how fast you were going, you couldn't calculate how far you had traveled, which meant you might crash into a reef or get lost in the middle of the ocean. So sailors came up with a brilliantly simple invention called the chip log. Here's how it worked. They took a piece of wood, shaped like a slice of pie, and weighted it with lead so it would float upright in the water. This wood was attached to a long spool of rope. But this wasn't just any rope. Sailors had tied actual knots into the line at very specific intervals, exactly 47 feet and 3 inches apart. When the captain wanted to measure speed, a sailor would throw the wood overboard. The wood would stick in the water while the ship sailed away, pulling the rope out. As the rope spooled out, another sailor would flip a sand glass, typically a 28-second timer. The sailor holding the rope would let it run through his fingers and literally count the knots as they flew by. 1, 2, 3. When the sand ran out, he'd yell, "Stop!" If 5 knots had passed through his hands, the ship was moving at 5 knots. That is the literal origin. We use the word knot today because 400 years ago, sailors were counting physical knots in a piece of hemp rope. But here's the million-dollar question. Why were the knots tied exactly 47 feet apart? Why not 10 feet? Why not 100? This is where the history of speed turns into the science of the Earth. You see, on land, we use statute miles. A statute mile is 5,280 feet. This measurement actually comes from the Romans. It was roughly based on 1,000 paces of a Roman soldier. It's a measurement based on walking. But you can't walk on water. Sailors navigate using the Earth's grid, latitude and longitude. They notice that the Earth is a sphere, mostly. A circle has 360 degrees. If you take just 1 degree of latitude and slice it into 60 smaller pieces, you get a minute of arc. Sailors decided that 1 nautical mile should equal exactly 1 minute of latitude. This was a stroke of genius. It meant that the map and the ruler were the same thing. If a captain saw on his chart that he had to travel 1 degree north, he instantly knew that was 60 nautical miles. No calculator required. And that brings us back to the rope. The sailors did the math. They calculated that if they spaced the knots 47 feet apart and timed it for 28 seconds, the count would perfectly equal the number of nautical miles per hour. So a knot isn't just a random speed, it is a direct link to the geometry of the planet. Okay, so that makes sense for ships, but what about airplanes? Why does a pilot flying a modern jet at 30,000 feet use a unit invented for wooden sailing ships? When aviation began in the early 20th century, there was no separate infrastructure for planes. The first long-distance flights were over oceans, and the only reliable navigation charts available were maritime charts. Early pilots like Charles Lindbergh had to navigate exactly the same way ship captains did, using the stars, the horizon, and the latitude-longitude grid. Since they were using naval maps and naval formulas, it made sense to use the naval unit of speed. Furthermore, planes travel long distances. If a plane flies from New York to London, it is traveling across the curvature of the Earth. Using statute miles, which are flat, land-based measurements, would actually make the math harder and less accurate over those long curves. Using knots keeps the math simple because it speaks the language of the Earth's coordinates. So next time you hear a pilot announce that you're cruising at 500 knots, you'll know they're not just using a fancy aviation term. They're using a unit of measurement that dates back to sailors throwing wood into the ocean, a unit that was physically tied into a rope, and a unit that is perfectly synced with the shape of the Earth itself. Cars measure speed based on walking. Ships and planes measure speed based on the planet. I hope you enjoyed this little journey into maritime history. If you did, please hit that like button. It really helps the channel. And don't forget to subscribe to Simple Things Surprising Histories for more stories behind the everyday world. Thanks for watching, and I'll catch you in the next one.